So why do we learn the determinants of matrices? So we can find the inverses. And why do we need inverses? If we have inverses of things, we can multiply and get an identity matrix, and that's going to help us solve equations. Because if we do A times A inverse or A inverse times A, we get the identity matrix, and that's how we can sort of do math from one side of a matrix equation to another side. So here's the formula for finding the inverse of a 2 by 2. What you have to do is you have to find the determinant, and then you do 1 divided by the determinant. Remember that we couldn't have a determinant of 0 to have an inverse? And this is the main reason why. Because if our determinant was 0, we'd do 1 divided by 0, and then the inverse wouldn't exist. Then what happens? What do we notice? These two, you see that those two switch? The A and the D get switched, and the B and the C add a -2. So you're going to do 1 over the determinant, switch the A and the D, switch one diagonal, make the other diagonal negative. If you do this every single time when you multiply one by the other, you will get the identity matrix. We could prove it if we wanted to by using all the letters and multiplying it out, and you'd find out that you would get 1, 0, 0, 1 as a result. So we know that we're going to need our determinant. This is going to be 6. This is going to be 5. So when we go 6 minus 5, we get a determinant of 1. If I call this matrix A, then A inverse would be 1 over my determinant, which is 1, kind of nice. Switch 3 and 2, make these ones negative, -1 and -5, and we have our inverse. Just to do a quick check to make sure that that is our inverse, watch what happens when I do A times A inverse. Well, that would be 2, 1, 5, 3 times by 3, -1, -5, 2. And you might start to see why some of them are negative and some of them are switched. Okay? When I'm looking for my answer, when I'm looking for the first spot, which is row 1, column 1, remember, I take row 1. I multiply it by column 1. 2 times 3 is 6, 1 times -5 is 5, and I get 1. When I want to find row 1, column 2, I'd take row 1, multiply by column 2, and notice how the numbers are the same, but one is positive and one is negative. So I get 2 times -1 and 1 times 2, I'm going to get 0. Row 2, column 1, same thing. The numbers are the same, but one is positive, one is negative. I'm going to get 0. Finally, wow, that's not what I wanted. Yeah, well, we get the picture. Okay, so if we use the white pen here, 5, 3 times -1, 2, we're going to get -1. Just so that you can see that that's actually what I did, let's make a beautiful heart here. Let's take the image that we had here, copy it, copy, and paste it. There it is. Yes, it was a 1. There we go. If I tried to move the original one, since it's behind, it's still behind and you can't really see it. But this one, you can definitely see that it's there. All sorts of fun tricks you can do with your smartboard. So here's the idea of why those singular matrices don't have inverses. That because you're dividing by the determinant, then it has no inverse, and that means it can't be solved. Oh wait, but we only solved the one, right? There's one for you to try. So we get determinant's 3, so our inverse will be 1 over the determinant. Switch these ones, make these ones negative. Of course, you don't have to write -0. And there's our inverse. Now you could, if you wanted to, because that's a scalar out in front, you could multiply that through. So you could write it either like this, or you'd have -1/3, -2/3, 0 still, and then -1. And that would show up. Again, you can do inverses as well on our calculator. So if we want to see if that shows up, I'm going to type that matrix into my calculator. So I got a 2 by 2. And then we started off with -3, 2, 0, -1. And we go to our matrix, type in matrix A, and then right underneath the math button is x to the -1. If you just type the -1, it will find the inverse. Okay. Again, the calculator always goes to decimals first. You can go to the math button. Not what I wanted. Go to the math button. Change it to a fraction. And you'll get the -1/3, -2/3, 0, and -1, like we had before. Okay? If you knew that the determinant was 3, and you wanted to, say, factor that 1/3 out of there, well, factoring out a 1/3 is like dividing by 1/3, which is the same as multiplying by 3. So if I go 3 times my answer, that should give me the values that were in there before I factored it out. So you could do that as well. Often I like, especially because when you're doing work with inverses, you're going to be multiplying. It's much easier to multiply with the whole numbers rather than the fraction. So we multiply with the whole numbers first and add that scalar at the end. So there's how we can get our inverse of our matrices. Yeah.
So since we now have
There is a formula for 3 by 3s. If you can imagine how the determinant formula for 3 by 3s looked, the inverse formula for 3 by 3s is even worse. So it's not in this course, we're not going to look at how to solve a 3 by 3 without our calculator. What we're going to do is type this into our calculator and solve it. While you're doing that, I will go online and find you the 3 by 3 method for the inverse, and then you'll realize why we don't do it. So you type this one into your calculator, do F inverse on your calculator. That's how you'll be expected to find inverses of 3 by 3s. So there it is with our calculator, the inverse. And now online I found for you how to find the inverse of a 3 by 3 matrix in 8 easy steps. And there's 2 methods. There's the classic way here, and then there's the wedge product method using Grassmann algebra. Now, it must be somebody in the plains that developed that kind of algebra. Anyways, so here, look at that. What do? You just find the determinant of the whole thing first, which we already know. We could do that without our calculator. We use the diagonal method instead of this method. Step 2. Write the transpose of the matrix. We know how to do that. That wouldn't be so bad. Find the determinant of each of the 2 by 2 minor matrices. So we do a whole bunch of little matrices and find a whole bunch more determinants. There's only 9 of them that you have to calculate. It's not so bad. Okay. Then you take your, we've got all the cofactors. We've got our Yeah, and we got to make a new matrix with a whole bunch of plus and minuses. That should be easy to do. All right, find the inverse by dividing this one in the previous step by the determinant from the first step. Okay. And then copy over the first two columns and rows with the transpose. And then this is the, well, that's only 6 steps. Here's method 2. That looks not too bad either, eh? So needless to say, are you okay with just doing it on our calculator? Okay, good.